After the tone, please state your name followed by the pound sign.
Series.
Your line has been muted.
She will be presenting new tools to assess condition of freshwater wetlands in the northeastern United States, multimetric indices for vegetation, soil chemistry, algae taxa, and water chemistry. We'll follow her presentation with a Q&A and a discussion of the presentation. This is me. I'm Kimberly Roth, and I'm your webinar moderator. I'm an environmental analyst with the New England Interstate Water Pollution Control Commission, or NUIPIC. I manage our wetlands program. Please welcome Kate Miller. Kate has worked as a plant ecologist for the National Park Service Inventory and Monitoring Program since 2007 and is based out of Acadia National Park in Maine. Kate develops and implements long-term vegetation monitoring programs in northeastern parks, including for forests, freshwater wetlands, and salt marshes. Kate has a BS in Natural Resources from Northland College and an MS in Ecology and Environmental Sciences from the University of Maine. Kate is currently in a PhD program at the University of Maine in the School of Biology and Ecology. All right, Kate, you're on.
Okay, I just took control. So I just want to make sure you can hear me.
You sound great.
Yeah, okay. Okay, so thanks for the intro, Kimberly, and also just for organizing this, and also to everyone for attending this webinar. So I'm going to be talking about some new tools that my program developed for assessing wetland conditions, and that have recently been published in Ecological Indicators. So most of what I'm talking about in the paper in Ecological Indicators, if you want more details, you can look at that source. So how do I go between slides? Oh, there we go. Okay, so just an overview of what I'm going to talk about. I'm going to introduce the National Park Service's Inventory Monitoring Program, the need that I see for regional wetland assessment tools, and then I'll go through the multimetric indicator development process that I did, and then results and discussion based on the MMIs that I developed. And then for the last part of this, I'm going to be using land use and rapid assessment metrics to predict the MMI. So I work for the National Park Service's Inventory Monitoring Program. We conduct baseline inventories and long-term monitoring of important resources and ecosystems, and we use this information to help guide management decisions in parks. So I work for the Northeast Temperate Network. Our parks are from Morristown, New Jersey, up to Acadia in Maine. And so we have a wetland monitoring protocol specifically in Acadia, but we also monitor forested wetlands as part of the forest health program in most of our parks. And so I approached this study mostly looking at wetlands condition in Acadia, but I was also interested in metrics that could apply to forested wetlands in my other parks. So specifically for wetland monitoring in Acadia, we use a three-tiered approach where we have 10 sentinel sites that we sample intensively using the National Wetland Condition Assessment Protocol. And there are also potential reference sites for the National Wetland Condition Assessment. And we also have continuous water level monitoring occurring in these sites. And these are hand-picked sites to represent like the best of the best wetlands in Acadia. And then we also have 40 rapid assessment sites that are randomly selected, and we only conduct the USA RAM developed by EPA, and then also a time search for a plant species list. And the rapid assessment sites we sample in between the years of the NWCA. So until the EPA's National Wetland Condition Assessment, most of the funding for wetland monitoring was state level, either for regulation or conservation, or even smaller levels like watershed-based. And so sampling objectives, methods, indicators, they often vary by state. And so even though wetlands don't necessarily change as you cross state borders, the methods and indicators are different enough that there's limited application across states, which is fine if you're working for a state level. But for my network, I needed indicators that could apply across the different parts of my network. Sorry, so we have state level indicators. And then the floristic quality assessment has been widely used but its calculation includes number of species present at a site in the index. It's therefore very sensitive to area sample. So if you're using a standard protocol like the NWCA, it's less of an issue. But if you want to work across protocols like our wetland and forest protocol, this becomes an issue. And so one of the few laws of ecology is that the more area you sample, the more species you're going to find. So the SQI would potentially be higher for a larger area sample, not because of better conditions, but because of more area sampled. There's also a well-documented latitudinal gradient with species richness, so that you would expect species richness to increase as you go towards the equator. So comparing the SQI between sites in, say, northern Maine and Florida may be less appropriate because the SQI would be influenced strongly by species richness rather than conditions. So the EPA developed a national vegetation MMI, or multimetric indicator, based on the National Wetland Condition Assessment data. So kind of backing up, multimetric indicators, they take multiple metrics, each of which are a relatively unique measure of condition, and combine them into one indicator to measure overall conditions. And MMIs are often more responsive to change in condition or disturbance than just examining each indicator in the MMI on their own. They're really powerful tools. And the National Vegetation MMI is a really powerful tool for assessing wetland condition using the same metrics across the U.S. They were the first to design a national MMI for wetland condition, and it's a huge achievement, and I'm not trying to take away anything from that. But for me, I need more than just a vegetation multimetric indicator, and particularly for working in parks, to justify digging holes in wetlands and parks, I really need to show that I'm using the data, and so I at least need soil indicators. And then water quality is also a big concern in a lot of our parks, and so I wanted a good indicator for water quality. And I think I also want to mention that you lose a lot of potentially strong indicators of condition that could help form management recommendations at local levels when you need metrics that can work across the entire U.S. So, and also for areas like Acadia, which are kind of on the lower end of this disturbance gradient, the vegetation MMI that EPA developed, it rates most of my sites as really high quality or as good. And this is great information to know, but it misses the disturbance gradient that is in Acadia. And I need metrics with a little more resolution to justify management recommendations. So if I tell maintenance staff in the park that runoff and sedimentation from the carriage roads are impacting wetland condition, but that site is rated good, it kind of weakens my message. So again, I need a little more resolution. And so I think we need a middle ground of geographic scope where wetlands are similar that will allow us to look at patterns of wetland condition across the landscape in a way that we haven't been able to before. So I used the National Wetland Condition Assessment data to construct the metrics. And a lot of you are probably familiar with the NWCA protocol, but just to give you a review of the kind of data that are collected. So they have 40-meter radius assessment area, and in that assessment area, we collect information about the site. Also, it's where the water and algae samples come from. And then there are 4 soil pits where you characterize the soils and then also collect samples for later analysis. And then vegetation plots that are 100 square meter plots where vegetation data is collected. And then around the assessment area is a 100-meter buffer that we collected information about the buffer, such as structures that are present to help characterize the influence the buffer has on the assessment area. And I also want to mention here that the protocols and the data quality and the documentation for the NWCA were really incredible and really did create a unique opportunity that allowed me to analyze their data and to build these regional assessment tools. So had they not been such high quality program, it wouldn't have been possible. Okay, so the objectives of my study were to develop MMIs using the National Wetland Condition Assessment data for vegetation, soil chemistry, algae taxa, and water chemistry. And I used Stoddard et al., which is a process that EPA developed. It documents for building MMIs. It's also what EPA used for the vegetation MMI. It's really well documented, really easy to follow, and I encourage anyone to look at that paper if they're interested in this process. So the second objective of my study was to determine if condition of the surrounding landscape can predict condition of the wetland. So this is both to kind of test the MMIs because of what we know how landscape influences wetland conditions, and also a test of our tiered monitoring approach with NETN, where we have a few intensive sites and then many less intensive sites, or level 1 and 2 sites. So a preliminary step that I took was first to figure out which sites to include in the MMI development. So I used multidimensional scaling with percent cover of plant species for each site. NMDS is basically a non-parametric principal components analysis ordination. So I used the NMDS. I started with over 200 freshwater sites in the Eastern US. Of course, I included my sites from Acadia because this is all for Acadia. And I removed plots that were west and south, like on the western and south ridges of the study area, until latitude and longitude were not in the first gradient. And I removed plots by Nwk level 4 ecoregions. So these are the NMDS results. I ended up with 166 plots. And so there is a latitude and longitudinal gradient in the data, but it's in the second axis. And the first axis is what's describing the disturbance gradient. And so this is exactly what I was looking for. I didn't necessarily expect there to be a disturbance gradient in the NMDS or for that to be the first gradient, but it's perpendicular to latitude and longitude, which means that it's not correlated. The disturbance gradient is not correlated with lat or long. Okay, so these are the sites that I included when I finished with the NMDS. And so we have a really high representation of emergent sites, forested sites, scrub shrub, less so for farms and unconsolidated bottom or aquatic bed. So the first actual step of the MMI construction was to determine reference sites that are the least disturbed from most disturbed sites. So I used number of stressors in the buffer plots weighted by distance from center. This is the approach that EPA developed. If you were at the Denver meeting last year or 2 years ago when they talked about it, it's also in their technical report. So that's how I looked at whether it was reference or most disturbed. So, and this is also where I strayed a bit from EPA's approach. So I only used for my reference sites the hand-picked sites that were based on best professional judgment to be high quality, least disturbed condition. And then of those sites, I also made sure they had no stressors recorded in the buffer plots. So if there was a hand-picked site, potential reference site that had a buffer stressor in the buffer plot, I didn't include it in the analysis as a reference site. And then for the most disturbed, this is a total of 2 or more stressors summed up in the buffer plots. And so this is where I strayed a bit from EPA's approach in that because I only used the reference sites that were hand-picked, and I did this because I didn't want to use more data. So by only using reference sites, I didn't have to analyze the data to look at the probability sites to see which ones of those were referenced, which EPA did, because it requires a lot of data, and I would have probably used up a lot of metrics that I wanted to use for later MMIs. I also want to point out the value of the buffer plots. Probably not alone in that the sampling the buffer plots was not my favorite part of the NWCA in 2011, but they ended up being really useful in my analysis. They were useful in the EPA's vegetation MMI. And so they're a great measure of buffer condition, and it really helped determine disturbance status of site. So think of that if you're out there sampling and not enjoying them. Okay, so here are the NWCA sites by disturbance class. So the reference sites are the green triangles, most disturbed are the red squares, and then the intermediate are either probability sites that weren't determined to be most disturbed, or the reference sites or potential reference sites that had a stressor in the buffer. Okay, so the next step after you determine most and reference sites are to compare, find metrics that separate by disturbance type. So we compared box plots and key statistics, and again, this is all in Stoddard et al. Once you find metrics that separate by disturbance type, well, then you want to look at whether they're strongly correlated or not. You also are looking for metrics that aren't describing the same biological phenomenon. And then also not correlated with strong natural gradients, such as latitude. And then finally, they need to have a signal to noise that's greater than or equal to 2. So signal to noise is the ratio of variance among all sites of a metric compared to the variance of repeated visits to the same site of a metric, so signal to noise. So finally, once you find metrics that fit all of what I just described before, you want to combine them into the MMI, so you convert the metrics to a 10-point scale and then combine. And so in some cases, folks that build MMIs, they actually weight different metrics, saying, you know, this is more important than the other, so they get there on a 20-point scale and the others would be on a 10 or something like that. All of my metrics are weighted equally. So next, then convert the 10-point scale that you combined to a 100-point scale, so it acts more like a percent. And then calculate thresholds between good, fair, and poor for each MMI. And so the threshold that separates good and fair is the lower 25th percentile of the reference distribution. The threshold between fair and poor is the lower 5th percentile of the reference group. And then you can rate each site using the thresholds. So for the vegetation MMI, I tested pretty much any metric that I could come up with based on the data, and a lot of these came from the literature. So even though I was kind of shying away from species richness, I still included it to see how good of a metric it was. I included species richness of both native and invasive species. I included index of wetness, which uses wetland indicator status as a scale from -5 to +5, where -5 is obligate species and +5 is upland. And so if you average the scores across the species present, you get this index of wetness. I also looked at percent cover by life form, such as woody, graminoid, or bryophytes. And then any coefficient of conservatism-based metric that I could find in the literature, I used. So that included the FQI, even though I was a little hesitant to use it. Mean C, which is just the mean of all the coefficient of conservatism values of each plant species present. And then I looked at weighted mean C and SQI, which is based on the weighted based on the percent cover of each species, and then percent cover of tolerant species. These are all native species that have a coefficient of conservatism from 1 to 4, and then percent cover of sensitive, which would be species with a coefficient of conservatism between 7 and 10. So the metrics that worked best for this one were mean C, percent exotic cover, percent bryophyte cover, and percent tolerant cover, percent tolerant cover of native species. I should mention that the vegetation data I used was the average cover averaged across all 5 of the vegetation plots for each assessment area. And also, I also wanted to thank Teresa McGee, because she provided me with species lists that included all of the CFCs and the wetland indicator status for each species. It saved me a huge amount of time and put me ahead and able to do this. Okay, for soil, I used the first soil sample collected within 30 centimeters of the surface. If a site didn't have a sample within 30 centimeters, I excluded it. I used all of the metrics that basically were provided by the NWCA data. So percent total carbon percent total carbon, percent nitrogen, percent total sulfur. I looked at bulk density, pH in water, pH in calcium chloride, cation exchange capacity, also concentration of cations. I looked at extractable acidity, phosphorus concentration. There were 21 trace elements that I looked at, and then percent aluminum, percent iron, percent manganese, and then percent clay and silt. So the metrics that worked best were percent total carbon, phosphorus, pH and calcium chloride, and cobalt. The bulk density was another strong contender, but it was strongly correlated with percent total carbon, also kind of describing the same biological phenomenon. And it also had, the percent total carbon had more samples to work with, but I don't know if you remember, but some of the bulk density samples had issues, so they couldn't be analyzed. So the higher sample size was ideal for the percent total carbon. And also what's useful about percent total carbon is that there was a meta-analysis by Marino, Mateos et al. In 2012. And they looked at wetland function in created versus natural wetlands. And they found that even after a century that a wetland was created, that the soil carbon storage was still well below that of natural wetlands. So I think total carbon is a really important wetland, or a really important metric to track wetland conditions. And also it's important for carbon sequestration. Phosphorus as an indicator of nutrients, it wasn't as strong, or it was a stronger indicator than nitrogen, so I included it. And then cobalt is a trace element. It's an indicator of sedimentation and surface water runoff. There were a lot of trace elements that distinguish really well between reference and most disturbed categories, but they were also strongly negatively correlated with percent total carbon. Is there any soil scientists on the call that probably know better than I do or be able to explain this better than me? But carbon and pH influence metal mobility in wetlands, which may reflect the correlation that I found between total carbon and a lot of the trace elements. And I guess release of cobalt into the soil is less strongly associated with organic matter and pH, and maybe why it works better for this metric. Oh, and I also want to thank Annie Rossi. She really helped with some of this analysis. I'm going to go back for a second. Helped me kind of make sense out of some of these metrics. And I forgot to mention that silica was another strong contender, but we weren't sure if this is reflecting condition of the soil or the vegetation, because a lot of species like Phragmites or Phalaris that tend to increase with disturbance, they also sequester silica, and it may increase in soil through decomposition, so it could have been reflecting that rather than changes in soil quality. So I didn't use silica as one of the metrics because of that. Okay. For algae, I looked at microcystin and then also natural units per milliliter of 193 genera of algae, and then I also grouped them by kind of life form, so blue-green algae, cryptophytes, diatoms, dinoflagellates, and green algae. So here are the genera that were best for the algae and the MMI. And I mentioned that algae was pretty tricky to build, and I have the least confidence in this MMI than the others. So there were a number of algae genera, and often ones reported in literature that separated reference in most disturbed sites really well, but many of those strong contenders also had a really strong east-west gradient in their abundance. And so it was difficult to find both genera that distinguished between disturbed and reference sites and then also didn't have a strong latitudinal or longitudinal gradient. And so over smaller areas like maybe northern New England, I could definitely see potential in the data for an algae MMI, but for the area I considered, it was just too big, and the algae MMI was difficult to build, and as you'll see, one of the weaker performers. For the water MMI, I used basically all the metrics that we could that were in the water data, so conductivity, ammonia, nitrate concentration, pH, total nitrogen, total phosphorus, and chlorophyll A. So sample size was a bit of an issue with the water MMI. There were only about, I think, half of the sites in my data set that actually had a water sample that I could work with. And you also notice that the metrics that I use are a little redundant with the soil MMI. I originally wanted to develop just the abiotic MMI that incorporated both water and soil chemistry, but with only half of the sites with water samples, it just seemed more appropriate to have a soil and water MMI separately. But if more samples are collected in the future, if we have more data to work with, I may try to combine water and soil chemistry into one abiotic MMI. So the low sample size also made it difficult to come up with good metrics, and also that there were fewer water chemistry variables, so I was only able to come up with 3 metrics to combine into the MMI. But they're still pretty commonly used metrics like conductivity, pH, total phosphorus that are used to assess water quality. And I'll also mention that chlorophyll A would have been a good metric. It had really good distinction between reference and most disturbed. But the signal to noise was really low, and it may have just been a fluke with the data that I was working with. But there was there was one site that was resampled that one of the visits had order of magnitude higher value for chlorophyll A than the original assessment, and so I couldn't use it because of the signal to noise ratio. Okay, so here are all the MMIs with ratings. So you see good separation between the reference and most disturbed groups for the vegetation MMI, the soil MMI, and the water MMI. The algae one is okay. There's also a nice range in the intermediate category, which it suggests, and we know, that there are high quality wetlands in the probability sites as well. And so this just shows with the original NMDS that I showed before that all the MMIs are following the disturbance gradient that we saw before, and they're not related to the latitude and longitudinal gradient that were in the second axis. And I'll mention that I didn't actually use the NMDS to inform any of the metrics that I wanted to use. It was just to say, okay, these are appropriate sites to use for the analysis. But it's nice to check back. Okay, these are the sites that were included in the study rated for the vegetation MMI based on good, fair, and poor categories. And are there any folks that were involved in the Vermont survey? I'm interested in what you think about the sites being rated poor, because you'll notice throughout the MMIs that they're rated poor, and I think something might be going on, and I'd like to get feedback on that. So here are the soil MMI ratings. And again, Vermont kind of rates low, but there's pretty good scatter throughout in the rest of the area. And then the algae MMI ratings, there were a fair amount of samples or sites that didn't have a sample. And then finally, the water MMI ratings, which you really see that there were fewer sites with samples to work with. Okay, so I also made a spreadsheet calculator that's downloaded from the NEPN website, and it's available at the website below. So people can easily calculate and rate condition of new sites. So you just type in the values for your site, and it will give you the score and the rating of the site as good, fair, or poor. So there's a tab for each one of the MMIs that I constructed. And as I get more savvy at programming with RSavvy, I'm hoping to build interactive website features instead of, having to download a spreadsheet calculator. I'm hoping that it's something that you can do through our website. So I'm going to use these MMIs to assess wetland condition in Acadia. I'm hoping other wetland folks in the region will adopt and test these MMIs. The more folks that are using the MMIs, the better understanding we'll have of, one, how good these MMIs were, also how condition varies across the area and over time. And so I'm not opposed to adjusting these MMIs as we have more information and they're tested in more areas. And then also as more folks apply this to the broader area, this will help me assess for my program whether trends occurring in Acadia and in some of our parks are specific to the park or if they're part of a regional trend. So if you're interested in using these MMIs, I'm happy to help you get started and to answer any questions that you have. Okay, so the MMIs that I built, they're based on pretty widely used metrics to assess wetland conditions, so including percent exotic cover, pH, conductivity, phosphorus, so no big surprises. And because the individual metrics that went into the vegetation MMI do not include species richness and rather summed percent covered by plant groups, the vegetation MMI may be less sensitive to sampling area and could be applicable to other protocols. And I'm interested in what other folks think about this, and if other folks apply this to different kinds of protocols, what the results look like. And as I mentioned before, algae was the weakest performing MMI for the study area, not because algae were poor indicators of disturbance, but just that the best taxa really had strong gradients in their distribution, and I had to exclude them. So for smaller areas, they seem like they'd be much better indicators of wetland condition. And then finally, and this may be what's going on in Vermont, is these MMIs are most applicable to depressional flats or slope wetlands where precipitation and poorly buffered groundwater are the main water inputs. If there's some kind of calcareous substrate or bedrock, the MMIs are not probably applicable to those areas, and that may be part of what's going on in Vermont. Okay, so this next part is going to get a bit technical, but bear with me because the results are pretty interesting, and hopefully I can explain it in a way that's useful. So the objective of this part of the analysis was to assess how well the surrounding land use and USA rapid assessment metrics can predict each MMI. I used random forest to do this analysis. Random forest is a machine learning method for modeling and predicting data. It's a form of nonlinear regression that generates many regression trees, which is why it's called random forest, using bootstrapped subsets of the data set to come up with an average model to make predictions with. So random forest has a lot of benefits over more common approaches like generalized linear models or analysis of variance. So compared with GLM or ANOVA, random forest regression has few underlying assumptions, is often more robust to outliers, can handle complex interactions among predictor variables better, and also has high classification accuracy. It's also really easy to use in R with random forest package. And if anyone is interested in learning more about random forest regression, I can send along a few helpful articles, including one that's called Machine Learning Without Tears, which is a really helpful article, really well written for this type of approach. So anyway, for my random forest analysis, my predictor or my response variables were each MMI, and then my predictor variables were percent of land cover types within 500 meters and within 1 kilometer buffer around the center of the assessment area using national land cover data set. And then I also included the USA RAM metrics. For the second phase, I looked at how well random forest could, or how well land use and USA RAM metrics could predict MMIs, plus I included vegetation MMI. So the predictor variables were all the metrics in the previous analysis, plus the VMMI score, the percent bryocyte cover, mean C, percent exotic cover, and percent tolerant cover, which were the metrics included in the VMMI score. And the reason I did this is that vegetation data are really easy for our program to collect. That's why we're doing it in the 40 rapid assessment sites. And so I wanted to see how well just collecting vegetation data and land use and USA RAM metrics could predict the other multimetric indicators of like soil, algae, and water. So this is the kind of the output you get from random forest. And so this is specifically for when I was using the land use and rapid assessment metrics to predict the vegetation MMI. So this is kind of the part one. And so this is a variable importance plot that shows which variables were most important in predicting the vegetation MMI. So you'll see that, for example, percent 1K is percent of the buffer within 1 kilometer, and then P500 is percent of buffer within 500 kilometers of that land use. So in this variable importance plot, agriculture, cultivated crops, and hay pasture within 1 kilometer radius of the assessment area were really important in predicting the vegetation MMI. Also interesting was that the total indicators, which is metric 4 of the USA RAM, and kind of a measure of topographic complexity, was an important metric in this random forest analysis. And so I have one of these variable importance plots for every MMI that I tried to predict with land use. And what's nice is it also gives you the percent of variance explained. So 43% of the variance in the vegetation MMI was explained by this model, which is really good. And then another way to assess how well the random forest model works is you have a 30% holdout data that you don't build your model with, and then you test how well the model predicts the data. So in this plot, this is observed versus predicted VMMI. And so the expected outcome would be that you have a slope of 1 and an R squared of 100 or 1. You never really have that in the real world, but at least here having an R squared of 0.5 is really high. I rarely see an R squared that high. And then also the slope being less than 1 suggests that the random forest is under-predicting high scores and over-predicting low scores. Under-predicting high scores and over-predicting low scores, which is pretty common for random forests, but at least the rank order of sites is maintained. So the low sites are lowest, the high sites are highest. They just are under and over-predicted. Okay, so kind of putting this all together in one table, these are based on the variable importance plot. So I ranked importance for each of the analyses, and I grouped them by the first 5. So if, for example, in the first column, if it has a 1, that means that that was in the top 5 of the variable importance. If it's a 2, that was within 6 and 10 most important variables, and then it goes on. And so what you see is that agriculture in the buffer was a really strong predictor of the vegetation, soil, and algae and water MMI, particularly for the vegetation and soil MMI. We also explained quite a bit of the variance in the data and then have relatively high R squared for both the vegetation MMI and the soil MMI. The water MMI was a little lower. A lot of that has to do with sample size. And then again, the algae was the kind of weakest performer. And then, so this next result is based on adding the vegetation MMI to the level 1 and 2 predictors to try to predict the soil, algae, and water MMI. And so here we have that the vegetation data or the metrics were really important for the other 3 MMIs. Now our variance explained goes up to 60% or 66% for the soil. The algae and the water MMI are also more variance explained. And then my R squared values also go up. Still not quite as much for the algae MMI, but a lot better than was before we included the vegetation data. Okay, so just to kind of summarize the results of the random forest, we found that land use metrics can provide a decent estimation of which wetlands are likely in the poorest condition and best condition. It maintains the rank order of conditions. With the addition of a site visit to collect vegetation data, this will greatly improve assessment of soil and water conditions. And then finally, the results validate our monitoring approach in Acadia, where we have intensive sampling in a few sites, and then we also have the rapid assessment and vegetation monitoring at 40 sites. And I think it's also just helpful that the results just make sense with what we know about the influence of agriculture and land use on wetland conditions. So the world makes sense with these results. Okay, so that's really all I have. I just wanted to acknowledge, so everyone with the NWCA has been super helpful for all of this, especially Greg Sarenbetz, probably way more helpful than he needed to be. Also, Teresa McGee, Annie Rossi, and Mary Compila all were helpful in this process. And then I also want to acknowledge Brian Mitchell, who was my supervisor at the time I started this. He's now working in the Southeast region, so no longer with us, but definitely helped. And then Brian McGill is my advisor at University of Maine, and so this is part of my dissertation. So thanks everyone for listening. I didn't see too many people drop off as I started. So I'm happy to take any questions that people have, and I hope we can get a good discussion and find out what you all think about these metrics.
Thank you, Kate. That was really great. I'm going to start opening up the phone lines here. I sent you guys all a note reminding you to please link up your audio with your web profile so we can accurately mute or unmute folks. If you have questions for Kate, this will be the time to ask them. And then again, if you are not currently speaking, please keep your phone on mute using your phone's mute.
Your line has been unmuted.
That way we can keep down on the chatter.
Great. Kate, I think this has really been excellent, what you've done in your presentation. I've been looking at New Hampshire's data and had talked with Teresa McGee because we had some of our forested wetlands that were in floodplain areas scored much lower than we would expect. So I'm kind of curious to hear whether any of Vermont's wetlands that scored low were in that same kind of universe.
Yeah, I would be interested to find that out too. I'm not sure if anyone from Vermont's on the call.
Yeah, hi, this is Tina Heath. I'm actually with the Vermont Wetlands Program, and I was involved in the NWCA back in 2011. So I'm also pretty curious about how the vegetation MMI turned out to be quite poor for most of our sites. We had 8 sites, and most of them I thought were in decent condition. We did have a couple that were considered disturbed in terms of having surrounding agricultural use and whatnot. But we did have like a nice cedar swamp wetland that we sampled, as well as a nice riverine floodplain forest associated with the Clyde River up in the Northeast Kingdom. And I thought that was actually one of our nicest sites, and I believe it scored as intermediate and then also still poor for the on the vegetation MMI. So I'm just trying to figure out, too, if you have any inferences or hypotheses on what that could mean. I know you briefly talked about it in one of your last statements, but if you could maybe elaborate a little bit, that would be really helpful. Thank you.
Yeah, so I think that probably a big part of the problem is just what the water sources are. So for like a riverine floodplain, I would expect it not to be appropriate for these MMIs because the water source is different. Most of the sites included in the study were either kind of perched wetlands or had poorly buffered groundwater, mostly on like acidic granite. And so any sites that don't fit that probably won't rate well, but not because of conditions, it's because they're different. And it was hard going through the data, and usually one of the drawbacks of analysis that's this big is that there are sometimes these outliers that don't quite fit the system, and because you have so many sites that do fit the system, like you can still come up with good metrics, but you have to figure out where the caveats are and make sure they're clear. And so I think Vermont and floodplain forests are those caveats where we can't use them. And so I showed the maps here because I wanted to see what people think, but I didn't publish them intentionally in the ecological indicators paper because I felt like there were some issues that I couldn't completely identify and that I didn't want them published so people would think that I'm actually rating them poor, but I used them to help inform the analysis. Related to floodplain forest or kind of forested swamps, I think that the Maine Natural Areas Program has been working on some kind of assessment tools for those kinds of communities. And I may be wrong if anyone's with Maine Natural Areas Program, maybe they can speak up, but perhaps that would help come up with something for the other states based on their work.
Do you think that this is Tina Heath with Vermont Wetlands again, but with the vegetation MMIs and relating to riverine floodplain forests, is maybe some of these scoring poorly because of looking at percentage of exotic covers or percentage of, more tolerant species, more facultative species. Does that weigh into this, where you're looking at areas that are depressional, that are only receiving, precipitation as their main source of hydrology, so you start to develop plant communities that are only very tolerant or specifically tolerant to a certain type of conditions, such as, groundwater that may be more acidic, like in bogs or in fens, for example. So you're getting plants that are super specific to their habitat. And so does that weigh into this potentially when looking at the vegetation MMIs? I know this kind of weighs into the FQAIs of areas, but I didn't know if this also weighs into the MMIs.
Yeah, it definitely does. So there's, like, rivering wetlands are disturbed as part of their natural condition. And so you're going to have more stress-tolerant species there because they have to be able to handle flooding and sedimentation and all of those things. And so, yeah, I don't think that they're appropriate for these MMIs. But most of the sites that were included in this analysis are not those sites. And so I just wanted to make clear that if you have those rivering sites or on calcareous bedrock, they're not appropriate for these MMIs.
So do you have you been looking into other types of indices to try to get to include some of these other types of wetlands that are not so specialized in terms of, plant natural communities at all?
I haven't, and part of why I haven't is because these MMIs work for my parks. So I haven't really had to go beyond. But I'm very interested in if other people have ideas on good metrics for those kind of sites.
Well, I think, this is Sandy again, one of the things that have been developed is the work by Mike Bordash in Minnesota, who's developed kind of a range of mean C values by wetland type, and he has them grouped by the range for disturbed sites and the range for more least impacted sites. And the floodplain forests are the lowest scoring of the whole range in wetland types. So, yeah, it's if you look up it's published in Development of a Rapid Floristic Quality Assessment. He has this chart, and there are like 15 different wetland types, and the forested wetlands, forested floodplains are at the bottom of the range.
Interesting. Hi, this is Kristen, Maine Natural Areas Program. I just wanted to jump in when there was a break because somebody was asking about our floodplain forest survey work, and I'm not sure that it's going to be helpful to help decipher or answer any of the questions that you were proposing, but the nutshell is that we're doing floodplain surveys in 2 different large watersheds in Maine, focusing on floodplain forests, and using FQI, ecological integrity assessment methodologies. So it's more to test out EIA in Maine and developing our own EIA methodology within the state. And we haven't done a whole lot of using EIA or even FQI outside of the forested floodplain communities. We've had, a couple dozen other sites, but not enough to really start to sort out how useful it is on the spectrum of conditions and types. We're starting to. But it's more been useful to compare between the 2 and now moving on to 3 in different watersheds, what the major differences are.
Kate, I have another question for you. This is Tina from Vermont again. I'm really curious if you could if you could elaborate for me on how you, or what you exactly did with the vegetation assessment that you tied in with the USA RAM, because here in Vermont, we also have our own Vermont Rapid Assessment methods, and we're trying to kind of build we're trying to build up our capacity in data and, you know, quick level 1 assessments across the state. And I'm really interested in hearing a little bit more about the vegetation end of it and how you were able to tie that into the USA RAM and how that was applicable.
Yeah, so kind of what we decided on is if we're going to be out at a site, we might as well at least document which species are there, which the USA RAM doesn't really do. You just write down % cover of the dominant species by strata. So what we do is we break up the 40-meter radius assessment area into quarters. And so we run tapes out in the 4 cardinal directions, 40 meters, and then we do a 15-minute search in each quarter and document every species present. And then we do the overall % cover of the dominant species, like the USA RAM. So we have both like a really rich species list for each quarter, and we get some frequency data off of that, like if a species in each quarter or just one. And then we also get the relative or the overall cover of the dominant species. That's how we've done it. We're able to do about 2 sites a day unless there's one that's particularly far away or nasty to work in. But in general, it's worked pretty well for us. And so now that this publication just kind of came out and I finished with the indicators for intensive sampling, I'm working to modify these metrics a little bit so that I can use them just for the rapid assessment data that I'm collecting. Did that answer your question?
Yeah, it does. And just with, you said you broke up your assessment area into quarters according to the 4 cardinal directions, and then you did a 15-minute search in each quadrant. Did you set up like a sort of grid or meandering method to sample the vegetation, or is it just kind of a basic walkthrough? Or?
Yeah, it's a basic walkthrough. There's 2 of us usually present, and so we kind of start at opposite ends and then just kind of stay away from each other as we're doing it and try to cover the whole area.
Okay, thank you.
Yeah. And it's documented in our protocol. If you're interested, you can read the SOP that documents how to do that, and it's on our website if that's helpful.
Yes, thank you very much.
Hi, this is Adam Natkiewicz from the Pennsylvania Natural Heritage Program. I have a question for you about the application of some of these data. You had mentioned something about requesting management action in sites that had ranked as good or high-ranking sites, and sort of how you would justify that. I guess my first question is, what do you foresee the applications of these MMIs being in that context? But also, if you have different wetland types and for instance, some of these calcareous fens ranking as poor sites, would you almost recommend analyzing those as separate units and developing a different set of MMIs for them, and sort of just making, compartmentalizing them and making the recommendations based on those different compartments rather than trying to find an MMI that works for both? Thank you.
Yeah, so I'll answer your second question first. I absolutely agree that if there are wetlands on calcareous substrate, they shouldn't be used to, or these metrics shouldn't be used to assess their condition. Based on the data I had, I couldn't necessarily figure out if those sites were or not, and so I just kind of included them. They really, for my purposes, they just added noise to the data because I didn't officially rate any sites, even though I showed the map just to kind of see what people thought about the patterns. I'm not actually rating those sites to say these are good or poor condition because that's what the EPA BMMI is for. So that's part of it. Yeah, they should be analyzed separately. I probably won't develop MMIs for the kind of calcareous sites or the sites that don't fit this study because, again, the sites that I need to use these in fit the model that I developed. For the application, so this is primarily related to wetlands in Acadia, and so up until we started monitoring wetlands in Acadia, we didn't really know a ton about what the impacts were of, there's a lot of development around wetlands in the park. Like they tend to be the vistas that people love to look out at because you'll have this wonderful mountain view that you saw a lot of the pictures in the presentation across wetlands. And so there are culverts and things that may be affecting hydrology in some places that I needed ways to document that some of the wetlands were not in as good a condition as maybe the park thought, because we don't have invasive species in our wetlands. And so that's usually what people see. They see purple loosestrife or Phragmites and they think, oh, obviously that wetland is impacted. But there's more nuance in the disturbance gradient in the park, and there's still improvement that we could be doing so that we're not impacting the wetlands. And so I'm hoping that I can use the MRIs to show the disturbance gradient across the park so that I can pinpoint areas that may be consistently affecting wetland conditions, such as sedimentation from the carriage roads.
No, thank you very much. That was very helpful. But we sort of have the opposite problem where we might have sites that are really rich floristically but have a really terrible landscape context, and trying to build confidence in those sites in terms of land managers, even though they might have really terrible landscape context. The FQI values might be really high for that site, but not to reduce the need for protection in those sites.
Yeah. When I noticed too that there were a number of the Pennsylvania sites that had really high quality that were in the NWCA, and I don't remember if those were reference sites or if they were part of the probabilistic, but yeah, that's interesting. It's kind of the opposite that you're dealing with.
Any more questions for Kate, or would anybody else like to share personal experience with their development?
Yeah, this is. Yeah. Go ahead. Kathleen? Yeah, go ahead. This is Kathleen Drake from EPA Region 2, and one of the take-home messages in the Denver meeting on reviewing the NWCA results, and which you mentioned earlier on in your presentation, was this targeted best professional judgment selection of reference sites versus not enough, inadequate data at this juncture to look at a filtering process like they did in the NWCA. I wondered if that's something that is bothersome for you, or something that you would look at with a larger data set. The result from the NWCA was that there were the BPJ reference sites didn't really correspond well with the reference sites that were selected through the NWCA filtering process.
Yeah, so I think it's just kind of it depends on what you are more interested in. I wanted more metrics and was willing to give up on sample size a little bit for the reference condition, whereas I think for the EPA it was important to get more sites, and so and also getting really, really high condition based on using more metrics. So I realized that there may be a slight weakness to my approach, but it allowed me to calculate more metrics. And I'm also hoping with the next assessment in this summer, there'll be new sites that I can test out these metrics with to see how well they do. And so I kind of, the reference sites that I use may not be as high as condition as some of the probability sites that were included as part of the reference sites in WCA, but I still had really strong separation in reference and disturbed, and they were pretty commonly used metrics to assess wetland conditions. So I'm comfortable with the results, but again, this is kind of an iterative process. This is about having metrics that are valuable and that we can use to assess wetland condition over time. So I do expect that there will be minor adjustments along the way just to make sure that it's doing the best that it can do.
Thank you.
sounded like there was another question or comment right before Kathleen started.
Yeah, this is Kathleen Walls, New Jersey DEP. I just had a question about your algae MMI. Did you separate algae and diatoms?
So I basically just used the data that NWCA provided. So it was separated by genus, and then there was also a category of diatoms, I think, if I remember correctly. And so I looked at just diatoms, and then I looked also at every genus level that was available in the data set, and then I also combined the data, the genus level into like the blue-green algae and a couple other groups. I'm a little on the fringe of what I know about
diversity
algae. Oh, sorry?
I'm sorry. Go ahead.
I'm a little on the fringe of what I know about algae, but I kind of used the data that was available and then used what was in the literature to try to figure out what might work.
I just wondered if did you run Shannon-Weiner diversity index on any of the data? No, I didn't. No. Is that something that that you've done or that you found useful? We're just working on it now. We did a Mid-Atlantic, took the National Wetland Condition data for tidal marshes in the Mid-Atlantic, and did look at the algal diversity and just picked diatoms and looked at the diatom diversity, and it was significantly correlated to the MMI and some of the other condition metrics. So I'm just wondering if a diversity index might actually work, whereas the data you worked with maybe didn't show, you said it was the weakest MMI, but you saw the gradients in taxa with lat and long, but I wonder if you used a diversity index that might kind of level it a little bit more.
Yeah, that's a great suggestion. Something that I'll look into. I was a little disappointed at kind of what I was able to come up with the algae because of the gradients that I was finding in the data. I did look at, I think it was like number of species, a number of genera, just to kind of get an idea of diversity, but it wasn't useful. But Shannon-Weiner may be a good approach, so I might try that. Do you have a publication or something that you can point to?
Not yet.
Okay, well, I'd be happy to see it whenever you guys have something. So thanks for pointing that out.
Sure.
Were there any more thoughts or anyone else would like to jump in before we wrap up? All right. Well, everyone, thank you for joining us today, and a huge thank you to Kate for presenting today. I just want, before you all take off, I want to call your attention to our next webinar. Second Thursdays of the month at 1:30, we will be featuring Lisa Rhodes of Mass DEP. She will be presenting on the Chicopee Watershed Monitoring and Assessment Summary and Findings. Also, we have now launched our Wetlands webinar website. You can find that at newepc.org/wetlands/webinars. You can watch old recordings and keep track of the new schedule. It also provides links to register for our webinars. So thank you again, and we'll see you next month.
Great. Thanks, Kate. This is great.
Thank you. Thanks for putting this together.